Hello everyone, this is Vikram and welcome to my channel. In this video, we will understand what is Crossplane and how to use Crossplane as an infrastructure as code tool. These are the various topics we are going to learn in this video. We'll start with what is infrastructure as code or IAC. Then we will move on to understanding how to use Terraform as an IAC tool and understand its architecture. What is Crossplane and what are CRDs and why custom resource definitions are useful in Crossplane, key features and advantages of Crossplane, and finally we'll understand the differences between Terraform and Crossplane. We will start with infrastructure as code. Basically, we all know what is infrastructure as code. We already learned this topic multiple times in Ansible and Terraform series. So what is infrastructure as code or IAC is? It is the process of provisioning, configuring, and managing infrastructure components like virtual machines, databases, networking components, and load balancers, etc. through code and automation. So instead of manually provisioning them through UI or through SDKs or CLI tools, we basically configure these infrastructure resources through configuration files. So tools such as Ansible, Terraform, and other configuration management and IAC tools read these configuration files and deploy the needed infrastructure for us. Terraform is HashiCorp's infrastructure as code tool. So using Terraform, you can define the whole infrastructure in the form of configuration files, which are human readable. And what Terraform does is it will read these configuration files and manage the infrastructure for you. So we use HashiCorp's configuration language to write these configuration files, which basically end with the extension known as .tf. So we already covered this in our Terraform series. And also this method is known as declarative method, where instead of writing the series of instructions to create the infrastructure, we define the infrastructure, like we define how the infrastructure should look like in the form of configuration files. And then what tools such as Ansible and Terraform does is it will read these configuration files and then it will create the infrastructure for you. So the most of the IAC tools like Chef and Ansible, so instead of calling them as IAC tools, we can call them as configuration management tools. So they follow client server architecture. So client server architecture means you will have a server component running and you also have client component running. But in case of Terraform, it is not based on client server architecture. It majorly uses the cloud providers APIs to configure the infrastructure. So whatever configuration that you write in the Terraform configuration files. So what Terraform does is it will read these configurations and it will contact the cloud provider through their APIs. And also Terraform is cloud agnostic. So you can deploy infrastructure to any cloud environment like Azure, AWS, GCP, and VMware, as well as on-prem environments. So this is the Terraform architecture. So where we'll define the complete infrastructure in the form of Terraform files. And we have Terraform core, which will have the Terraform binary and various Terraform plugins like providers and provisioners. So providers are majorly responsible for contacting the end resources. Like, so if you have AWS provider, so this provider will have all the APIs required to talk to the AWS. Similarly, Azure provider, so it will have all the APIs that are necessary to talk to the Azure cloud platform. So similarly, we have provisioners. So we'll talk about provisioners. It's not required as of now. Basically, once you provision the infrastructure, so if you want to configure the infrastructure, you have two ways. One is to go for Ansible. The other way is to use provisioners like remote executioner, where it will just execute remote commands on the infrastructure that you create. So now once you have the Terraform files, by executing simple Terraform commands, so Terraform binary can read those configuration files. And by using the concept of providers, it can actually talk to the end infrastructure like AWS, GCP, Azure, etc. So as we already discussed, so Terraform majorly uses the cloud providers APIs in the form of Terraform providers to talk to the end cloud resource. So if you want to download or understand about these providers, you can go to Terraform registry. I think it is registry.terraform.com, where you can see all the publicly available and community uploaded Terraform providers. So that will help you in creating various cloud resources. And once you have the Terraform configuration written, so you have multiple commands to execute. So first we will initialize your Terraform configuration, where it will download all the required providers to talk to the the end entities like your AWS resources or Azure resources. Then we can do plan, where it will just show you a dry run or a preview of what infrastructure Terraform is going to create. Then if you apply, basically the end infrastructure will be provisioned for you. So it can be it can be AWS, Azure, Alibaba Cloud, Heroku, VMware. It can be anything depending upon the provider that you use. And creating a simple AWS EC2 instance is as easy as writing some resources in the form of HashiCorp configuration language, and Terraform does whatever it is required to provision this infrastructure for you. So you don't have to learn any separate programming language. And I don't think HCL syntax is very difficult to understand. So by simply understanding HCL syntax, you can create resources in any of the cloud environments. Now we understood what is Terraform. Let's understand what is Crossplane. So Crossplane is a CNCF graduated project. It is basically a framework to build platforms with Kubernetes resources. So when we say about build platforms, so it is about creating cloud resources. It can be virtual machines, it can be databases, networking, or it can be a combination of a complete platform. And what is advantage of using Crossplane is you don't have to learn any other language like HCL syntax. So we can provision the infrastructure the same way you create pods, deployment services through Kubernetes YAML files. Simply you define the required infrastructure in the form of these YAML files, and Crossplane does whatever is required to create this resource for you. So this is an overview of the Crossplane architecture. You still have a lot of controllers and other components running inside the cluster, but this is just an overview of the Crossplane infrastructure, where you have Crossplane components running within the same Kubernetes cluster, and these components are responsible for creating these cloud resources for you. It can be any cloud resource. So Crossplane is an open source multi-cloud control plane, and it is basically a Kubernetes add-on. So let's say if you want to fetch the metrics of pods and nodes, you would actually install metric server inside the Kubernetes platform. Similarly, Crossplane, it is also a component that runs inside your existing Kubernetes cluster, and this is responsible for managing cloud resources and infrastructure for you. So Crossplane aims to unify all APIs in platform engineering. So it can be APIs belonging to any of the cloud platform. And what Crossplane does is, by simply utilizing Kubernetes API and Kubernetes controllers, it can actually control the infrastructure for you. It basically uses these Kubernetes controllers to manage cloud resources. And as we already discussed, in Kubernetes, if you want to create a pod, you simply write an YAML file for the pod. Similarly, using Crossplane, you can define the infrastructure in the form of a same YAML file, that how you define pod, deployment, or a service resource. And what Crossplane does is, according to the Crossplane, these are all custom resource definitions. So if you want to create an S3 bucket in AWS, it is a custom resource, right? So what Crossplane does is, it will read all these custom resource definitions that are exactly they are written in the same YAML format, the way you write pod or deployment definitions. And when we talk about managing cloud infrastructure, it can be anything, as we already discussed. Like we can manage AWS resources like EC2, VPC, S3 from the same Kubernetes cluster, the same way you manage pods and other resources. So let's say I wanted to create an EC2 instance. What I do is I'll write an YAML file. And what Crossplane controllers does is, it will read these YAML files and simply create the infrastructure for you. It can be any infrastructure on AWS, Azure, Alibaba Cloud, or GCP, etc. So once you have the YAML file, then you can use Kubernetes native commands like kubectl create or apply to simply create, destroy, or update that cloud resource, right? And we already talked about Terraform providers, where providers provide the APIs to talk to the cloud resources. Similarly here, Crossplane uses same concept of providers, and these providers are responsible for talking to the end cloud infrastructure through cloud APIs. Let's say I wanted to talk to AWS to create an EC2 instance. Now what I have to do is I have to run this AWS provider as a controller inside the Kubernetes platform. And now if I create a CRT that that creates an EC2 instance, so this AWS provider can read that CID and create that resource for you in the AWS cloud. Right. So in Crossplane, you define all these infrastructure components in the form of CRDs, and that too using the same YAML syntax. Now, if you don't know what are CRDs, basically in Kubernetes, a CRD stands for custom resource definitions. So these are very powerful feature when you talk about Kubernetes. Basically, they extend the functionality of Kubernetes API. So let's say you created a simple Kubernetes cluster using Minikube. So within that cluster, you can only create resources that are supported by Kubernetes, like pods, deployments, services, cluster roles, cluster role bindings. But if I have to create a resource that create an EC2 instance resource, it is not possible because Kubernetes actually doesn't have any such APIs, right? But what CRDs does is, so they extend the Kubernetes functionality by through these custom resources and their schemas. So this enables you to manage or automate resources that are not actually part of core Kubernetes. Okay, so the part of core Kubernetes components are pods, services, and deployments. Right? So this is how these CRD work, and these are all the key components. Like first thing is custom resource definition. So first you need to define what sort of custom resource that you wanted to create and how that custom resource should look like. Basically, it is a schema, right? So if you talk about pod, so pod will have a name, pod should have a container image, container port. So that is the complete schema. So similarly, if you want to create any resource, you need to have a definition that specifies the structure of the resource, various attributes, validation rules, right? So when you create a CRD, create a CRD, you effectively create a new resource type in your cluster. So let's say I created a CRT. Okay, so, and if you see the resources inside the Kubernetes cluster, you would see a new resource type of this. And custom resource, you already have a definition written. So once you have the CRD defined, you can create instances of that CRD. Let's say I wanted to create an EC2 instance in AWS cloud. So I have a definition. So it is a schema. Then in order to actually create an actual instance, I need to consume that schema and write an actual definition, right? So if you take this as a blueprint, custom resources are like objects of that class. If you coming from OOPS background, right? And controller. So what is a controller is, let's say you have CRD in place and you also created a custom resource, but who is going to understand this resource? Like what resources are to be created? So this is where controllers comes into the picture. So in order to manage a custom resource, you need to have a controller that basically watches for any changes to the custom resources that you do, and it will take action depending upon the resource that you have created. So that action can be creation, deletion, update, right? So if you want to understand more about the Kubernetes custom resource definitions, you can visit this link. So where they create a custom resource definition, you can see the custom resource definition follows, I think, so there is this schema, yeah, Open API v3 schema. So where they define various, specs required and various configurations required. So this is, you can take it as a template. And then in order to create an actual resource, you need to create custom objects that are based on the custom resource definition. So this is how you create a custom resource, and this resource should follow the definition. And simply you can use kubectl apply and all those commands to talk to the these custom resources. If you see, so we created a custom resource, right? The name of the custom resource is cron tabs. Now, if you try to get all the API resources, or if you want to get that resource, it is possible. So if you don't have the custom resource definition, and if you simply do kubectl get cron tab, it won't fetch the output because this resource may not be available. Okay. So these are all custom resources which basically extend the Kubernetes API. So now we understood what is CRDs. So basically Crossplane also uses CRDs. Okay, so we define infrastructure in the form of a CRD. You have a controller that understands this CRD and provisions the infrastructure for you, right? And one important thing we need to remember in Crossplane is state reconciliation. So what is the meaning of this is, let's say you created a resource in cloud using Crossplane. And what will happen if someone manually deletes or modifies that resource, right? So what will happen in case of control plane is cross plane is, so cross plane basically monitors that resource for you. If it is somehow modified or deleted outside the Kubernetes, the Crossplane reverses that action immediately, and by either recreating that resource or modifying the resource so that the state will be brought back to the desired state. So there are two states, as we already know. So there is this desired state and we have the actual state. So if the actual state is having an EC2 instance up and running, if someone deletes the EC2 instance outside Kubernetes, so the actual state of the EC2 instance is stopped state. Now what Crossplane does is, it will again bring it back to the running state. So this is called reconciliation loop, and Crossplane always run this loop to make sure that the desired state and the actual state are always matched. And once you have the Crossplane installed, you'll be able to see uh, two pods running inside Crossplane system namespace. So one is the Crossplane and the other one is the RBAC manager. And once you install Crossplane, it also installs some custom resources for you. You can see once you get all the API resources in the cluster and grep for Crossplane, you will see a lot of new resource types like compositions, composite resource definitions, which we call the XRDs. So basically, these are also CRDs, but in case of Crossplane, these are known as XRDs, composite resource definitions and compositions. It is very difficult to understand as of now, but when we talk about the architecture, we'll understand various platform components of Crossplane. Now coming to the features of Crossplane, so we know that Crossplane basically abstracts everything on top of various cloud providers. Okay, so you don't have to understand anything about how the Crossplane talks to the cloud platform. Okay, so you just create a resource and Crossplane make sure that that resource is always created, and it also uses the Kubernetes native YAML files to manage describe and manage the resources across multiple cloud providers. And the second feature is composite resources. So this is nothing but custom resource definition that we use to create and manage the resources. Okay, but composite resources are different from yeah, so this is a newer term actually. So composite resources, composition, again we'll understand in depth about these two terms when we talk about the architecture. And also using Crossplane, you can deploy multiple resources at once. Like you can deploy EC2 instance, VPC, a lot of things like load balancers together using a single YAML file, which we call it as a composition. So you can deploy individual resources, or else you can deploy a composition, which is basically multiple resources deployed together. And we have the concept of providers, right? So providers in the sense, here we have if you take the case of AWS provider, so this provider in Crossplane runs as a controller to interact with the AWS cloud, right? Similarly, you have Azure controllers, GCP controllers, etc., running in the cluster. And other feature is policy and governance, where we have a policy engine in Crossplane that enables you to enforce certain policies across your infrastructure resources, right? If you have policies, that let's say I have to use tags as a mandatory argument for creating the EC2 instances, then I can use this as a policy, right? So there are a lot of policies available in Crossplane. And we already know we can manage the whole infrastructure in the form of a simple YAML file. So we can also use GitOps approach to manage the infrastructure, right? So we can basically maintain all these configurations of the platform in a separate Git repository, and we can use GitOps approach to properly manage the infrastructure. Multi-cloud and hybrid cloud, as we already said, we have a lot of cloud providers, so that managing multi-cloud environments is pretty much easy with Crossplane. Extensibility, so using creating your own custom resource definitions, you can definitely increase the scope of Crossplane. Like we can extend the functionalities of Crossplane even more. Advantage of Crossplane, first is drift detection. So in case if you're managing your infrastructure using Terraform, right, it is very difficult to find these drifts, because if someone goes and manually modifies infrastructure, Terraform wouldn't know, right? Until someone refreshes the state, they wouldn't know that they wouldn't know of the manual changes that are done outside of Terraform. But in case of Crossplane, so Crossplane, since it works in the form of a controller, right, we have controllers like deployment controller, endpoint controller, where in case if one of the pod of the deployment is deleted, automatically deployment controller will provision another pod for you, create another pod for you. Similarly, we have provider controllers here. So AWS provider controller. So these controllers will see if the desired state is matching the actual state. If someone deletes a resource in the cloud manually through management console or through AWS CLI, so automatically Crossplane will detect this drift, and it will automatically recreate that resource for you. No code and Kubernetes native. So here we define the infrastructure in the form of YAML files. So you don't have to learn any new language to manage the infrastructure now. If you know how to create resources like pod deployments, it is very easy to manage the cloud resources as well, right? And infrastructure as code, as we already know. So we write YAML files for defining the infrastructure. So these YAML files can be version control, and uh, it is very easy to share as well. And you can also automate this infrastructure provisioning through GitOps. And the final topic, Terraform versus the Crossplane. The first one is dry run. So basically, Terraform and Crossplane are both used as infrastructure as code tools, but they have very different purposes and characteristics. So first is dry run. So using Terraform, you can see a preview of what infrastructure your Terraform is going to create, right? Using Terraform plan. So you have that preview. But in case of Crossplane, you cannot actually see that plan. So if you have the YAML file, so automatically that YAML file has to be run in order to create the infrastructure. So there is no dry run. And the second difference is reconciliation mechanism, which we already discussed. If someone makes changes outside of Terraform, these changes will not be known by your Terraform. But in case of Crossplane, if someone changes anything outside the Crossplane, Crossplane automatically modifies that resource due to state reconciliation. Language. So Terraform uses HCL syntax, okay, which is again a domain-specific language. However, Crossplane uses YAML, which we already know, which everyone knows, because if you know how to work with Kubernetes resources, it is very easy to understand how to write custom resource definitions for managing cloud resources. Community and support, both has a very good community support, but Terraform has larger community because it's been in the market for a very long time. Crossplane being a very new tool, although it has many providers already onboarded, okay, and it is fast growing. If you look at the other difference, so Terraform basically Terraform scripts can be invoked through bash scripts, because Terraform scripts means we only have fewer commands like Terraform init, plan, apply, right? So those can be automated using shell scripts. But in case of Crossplane, okay, so we also have an API kind of an interface. This API is not for Crossplane. These APIs are for Kubernetes. Let's say by using a Kubernetes API, I can get the list of pods, right? I can get a list of deployments. I can even delete the resources inside the Kubernetes cluster, either through kubectl, or you can use SDKs or client libraries through Python or any other programming language, I can directly control the Kubernetes resources. And since Crossplane uses these resources to manage the cloud infrastructure for you, so if I create EC2 instance through Crossplane by using Kubernetes API, I can easily get the information about that resource. So this is about introduction to Crossplane. In the next video, we'll understand the architecture followed by how to install Crossplane. Thank you.